Now let's talk a little bit about overriding methods. So I'll copy this and we use over here. All right. So now, what if I defined, actually, instead of calling this G, let's just call that F. So now, what if I have F defined at the B level? When I create B of 5, I'm going to create an instance whose X attribute is 5. Now I call F. Which F? Well, the answer is B's F. Now, because I defined F at the B level, it overrode or replaced the one at the A level. So we should see 5,000 come out of here, and there it is. Wonderful. So what about if I wanted to have an init at the B level that took not only X but also Y? I said self.x is X and self.y is Y. And to prove that we're doing that, we will go ahead and have this be self.y here. And now if I do 5, if I try to run this, it won't work because it says it's missing the y. I'll do 5, 6 and run this. And now look, it worked. It initted and it went ahead and used y in B's F. Show you that A is still working. Print A of 5 dot F. And we should get, the init will work just with 5, and we should get 50, and there it is. Now, this is all close to well and good. The problem is this. When I'm creating a B has to be an A. A human has to be a mammal. So we want to first create a complete A, and that's what this line here is doing. It's just a copy of that line. To show you what I mean, what if I did here, print, you just created an instance of A. So when we get one of those for this A, but we do not get one of them for this B. It didn't print that out, even though B is an A. And the reason is because this code here was meant to be this code up here. One thing I can do is copy that and paste it here. It's a terrible idea. Copy pasting code like that is a terrible idea. First, if there's a bug in the code above, I just replicated the bug. Ugh. Second, if I fix the bug up here, but not down here, now I've replicated and mutated the bug. Terrible. Second, even if there is no bug, if I, after the fact, change my mind and say do something else, or do something more up here, I have to go find everywhere where I copy pasted this and copy and paste that as well. That's got to be screaming to you that that is not the way forward, because it's not. The way forward is instead to right here, call the init method of my superclass on me. That's not quite Python, but the idea is to create a B in its constructor, first go and create an A, and then do the B specific things here. This is in fact what we want to do. So now to do that, the way you call your init method on the superclass of me, Python 3 has the function called super. Super is just like self, but instead it's treat me as though I'm an instance of my superclass. So when you call super inside B, it treats self as though it's an A. If you called super inside the human class, it would treat you as though you're a mammal. It goes one level up in the class hierarchy. And now we want to go ahead and init here. And now we only pass in whatever this one needs, which is X. And we run this. Watch what happens. We create an instance of A, that's this one, which works just fine with 50. And then when we create this B, it actually says we create an instance of A because an instance of B is an instance of A because humans are mammals, because B's are A's, because to create a B, first you go and create an A. This is the clean way to override init. Now, so we have overridden init and we've overridden F. They work similarly but differently because F is completely replacing the F above, whereas init is not completely replacing, it's calling the superclasses init and then doing more. You could do the same here because we can do, for instance, this plus super dot F. And now this will do for b of 5, 6, this will be 1,000 times 6, or 6,000, plus the super. It'll go up to the super classes f and add in this, which is 10 times x, or 50, 6,050. And there is our 6,050 right there. Okay,